If you blow hard enough, could you make yourself float in the air? Is the moon made of cheese? Welcome back for episode 5 of Science at 6 with Cambridge Science Centre. My name is Alex and I'm this week's presenter in the centre. Last week our theme was feathery fossils, which I hope you all enjoyed. If you'd like to check out last week's activities, just check the description below. And you can email us your results and questions to openupscience@cambridgesciencecentre.org or tag us on social media. Last week we challenged you to make and excavate your own ice fossils. I'm sure you all got some brilliant results. I have one here that was made earlier, which we are going to excavate together. I have no idea what's inside, so it's going to be just as much a surprise to me as it is to you. We're going to be using some hot water, some cold water, some salt and a spoon. We are going to reveal what is hidden inside the ice as carefully as possible. Right, so I've got my scissors here. I've got my balloon. I'm just going to cut that open. See that? Some air escaping. And inside, I've got my ice fossil. I think I can see already what that is. So inside, so pouring some hot water. Now a bit of salt. Cool. As you can see, the hot and cold water is making the ice melt as it is heating up and turning into water. The salt is helping speed this process along as it reacts with the ice. The more the ice melts away, the closer we get to excavating our fossil. And there we go, wow, a shell, cool. Imagine if we had used a hammer to get inside. It might have been a lot faster, but who would want a broken fossil? Certainly not 11-year-old Zhenya, who discovered the Sopkaga mammoth in 2012. One of the best woolly mammoth discoveries ever made. Some mammoths have been so well preserved, some scientists believe we might even be able to clone them one day, bringing them back from extinction. Could we clone a velociraptor or a triceratops from fossils? Probably not. To have the chance to clone an organism, our fossil would have to contain some soft tissue, such as muscle. Velociraptor fossils come from remains that are tens of millions of years old, meaning that it is highly unlikely any soft tissue will have remained, even if it was frozen. Woolly mammoths, however, lived as recently as 10,000 years ago, way more recent, meaning a lot less time for soft tissue to decay. With them being frozen as well, the chance of preserving some soft tissue is much greater. Want to know more about how fossils form? Check out the video from the Natural History Museum in the description. Time to see what you at home got up to last week. Over to you, Mario.
Hello everyone, my name is Mario and I'm going to be looking at some of the work you've done this week. Esther age 8, Ada 6 and Thora 2 were given the brief that they had to rescue the dinosaur specimens from their glaciers so they could be transported to the museum in one piece. They tried chipping at the ice, brushing, drops of water, jets of warm water and even breathing hot air on the ice to see how fast it could melt. So well done for getting out your dinosaurs nice and safely. Keep sending us your pictures of the activities that you've and the solutions to our weekly challenges and we'd love to see how you get on. And you may even see your work featured next week. We've also had some questions sent in with Josh age 10 asking, have dinosaur fossils been found in the UK? Well, yes they have. That's a very fantastic question. Dinosaur fossils have been found in every continent of the earth, including Antarctica and of course Europe. Most of the UK's dinosaur fossils, however, have been discovered in the south of England at coastal sites such as the Isle of Wight and the Jurassic coast of Dorset. However, the first dinosaur bones ever to be discovered in scientific literature, possibly from a megalosaurus, was discovered from a limestone quarry in Oxfordshire in 1824. Well, I say dinosaurs, but it wasn't until nearly 20 years later, in 1842, that the term dinosaur was used to describe a group of animals, including the megalosaurus and other recently found great lizards such as the iguanodon. Our next question is from Ella, age 8, who's asked, what's the oldest fossil that's been found? Well, in 2017, some scientists in Greenland discovered ruins of colonies of ancient bacteria known as stromatolites from about 3.7 billion year old rocks. So, thank you very much for sending in your questions, and if you have any questions about this week's topic, please make sure to send them to us and we'll try our best to answer them on next week's show.
Super questions and super pictures, everyone. Keep sending us your results and questions to openupscience@cambridgesciencecentre.org or on social media. Now, for another demo. If you use your breath, can you lift yourself off the ground? Not quite. But Katy, Mia and Mario are about to show us something really interesting using a similar idea.
Hi, my name is Katy and I'm a science communicator here at the Cambridge Science Centre. Today we're going to be looking at friction. Now friction is a force between two surfaces that are sliding past one another or trying to slide past one another. It is this that can slow a moving object down or stop it completely. We're going to use a CD today to look at friction, and this will have different amounts of friction on different surfaces, so the rougher the surface, the higher the friction, so the slower it will move. So even on this table, which is fairly shiny, it will still stop quite quickly because there's still quite a bit of friction. So we want to reduce friction quite a bit, and the way to do that is to build a hovercraft. So to do this, you'll need a CD, you'll need a bottle cap, one which moves up and down, you'll need some glue to stick it onto the CD itself, and a balloon. This is what I have prepared, ready to do the hovercraft. And watch what happens when I release the lid and let the air out. As you can see, moves quite freely. So this is because as the balloon deflates, air is moving out of the balloon through the hole in the CD and moving in between the CD and the table. This creates a layer of air, therefore reducing the amount of friction between the two surfaces, meaning it can move nice and easily across the table. You can give that a go quite easily at home, just with a few things you've got lying around. But what if we want to make this hovercraft on a larger scale? In a larger version of this hovercraft, the leaf blower is going to replace the balloon, and this is going to replace the CD. As you can see, there are air holes on the bottom of this surface, which will create the air layer between this and the floor. So introducing Mia, glamorous assistant, and she will be getting to go on this hovercraft.
Cool. Thank you, Katy, Mia and Mario. You may have heard of hovercraft before. You may have seen a video of one, or if you're really lucky, you may have ridden on one. By using the same principles that allowed Katy to make the CD float, with a little more power, we can increase the mass we can lift. Expert engineering has allowed us to create vehicles that can carry people on an air cushion, which even work over water. It's all about reducing that friction. But how are hovercrafts and space travel related? If we pushed Mia, but Mario or Katy wasn't there to catch her, she would just keep going until she bumped into something. This is an example of Isaac Newton's first law of motion. A moving object will keep moving until a force stops it. The force of friction wouldn't stop her moving, but the force of a wall would. But what's that got to do with space? Well, if we were floating inside a space station, there is very little gravity and there's virtually no friction at all. So once you start gliding one way, it might be hard to stop yourself and end up banging your head. Whereas on Earth, gravity pulls us down, allowing friction to act between our feet and the ground, stopping us floating, slipping, sliding all over the place. See how to have a go yourself in the description below, and send us a picture of your homemade hovercrafts to openupscience@cambridgesciencecentre.org or via social media. Now, I'm not exactly a space expert myself, but Joe knows somebody who is. Matt Kenworthy, Associate Professor at Leiden Observatory, Leiden University.
Hello, Professor Kenworthy, and thank you for joining us.
Hello.
I wonder if you could start by introducing yourself to our viewers and tell us a little bit about what it is that you do.
Sure. So my name is Matthew Kenworthy, and I'm an associate professor at Leiden Observatory in the Netherlands. So it's about 20 miles south of Amsterdam.
So as an astronomer, what is it about your work that makes it really important to you?
So what I really like about astronomy is that I get to use some of the biggest telescopes in the world to make brand new discoveries in the skies above us. So when I was younger, I always looked up at the stars and I saw the planets, and always wondered if there were more planets and what other things were going on around other stars.
So part of your work is to teach students and to share your work with other people. What is it about that aspect of your job that you really, really love?
For me, it's really exciting to teach students, because then you get to see them get excited about astronomy themselves. And also it turns out that I'm always learning. So even every day, even now, I'm always learning something new from reading astronomy research papers or when I'm teaching to students. So it's really cool that I still get to learn stuff all the time.
I think astronomy is something that a lot of children might have thought about studying at school. What subjects did you study at school, and did you always want to become an astronomer?
So I think I was a little bit odd, because ever since I was a kid, I wanted to become an astronomer, but I didn't know how to go about it or what it really involved. A really good friend of mine from school, his dad went to a local astronomical society. So he took me along with my friend, and we heard talks about astronomy and planets and stars. And then I found out that in order to do astronomy, you have to be very good at mathematics. And I wasn't good at mathematics at the start, but it turns out that you can learn the stuff you need to in mathematics. And it's one of the most important tools that I use day to day when I'm trying to calculate the positions of stars and planets and understand what's going on in the universe.
Brilliant. What about the other people that you work with? Do they have similar backgrounds to you?
So yeah, there's a fair mix of people. I mean, the one thing altogether is we're passionate about astronomy, and we're finding out lots of different things. Astronomy's a very, very big field now. So there are lots of different areas of astronomy. So sometimes we build universes in computers, and you have to learn how to program a computer and run big simulations. Other people do lots of observations. So they go to a telescope and take pictures of the universe, and then we try and work out what's going on around nearby stars and in the more distant galaxies. And also there are people who build the instruments, build the cameras, and this is something which I did in my career.
Oh, that is amazing. You can actually use your practical skills as well as your mental skills, and then see the results of them at the end of it. It's brilliant. Finally, Matt, can you tell us about somebody who inspires you and why they have?
So I remember reading about Marie Curie when I was much younger, and I was inspired because she worked extremely hard. She took this material called pitch blende and basically boiled it down and reduced it down to discover a brand new element called radium. But generally, I'm inspired by many people in my department and in my field, and I get inspired by different things and different people all the time. I think it shouldn't be just one person. There should be many people who inspire you in many different ways.
You can keep pushing on and keep learning.
Yeah, absolutely.
Yeah, well, that's fantastic. Thank you for joining me today, Professor Kenworthy. It's been a great pleasure to talk to you.
You're welcome.
That interview was out of this world. As you may have guessed, this week's theme is all about space. In fact, our theme this week is over the moon. That's right, it's all about our not so cheesy friend in the sky. The moon's surface is not brie, cheddar or mozzarella, but is in fact rocky. Under the surface though, scientists aren't so sure, but still most probably not edible. Did you know our one and only moon is 239,000 miles away, although on some nights it may seem a little closer? Did you also know that the moon is responsible for the tides coming in and out? Check out our activities in the description and our challenge of the week too. which this week is an investigation into impact craters and what happens when a comet, meteor, or asteroid strikes the surface of the moon. And finally, please send us your questions and pictures of your work. We will take a look at some next Monday on Science at 6. Thank you and goodbye.